Good evening. I'm Sam Brenner, here reporting for EPSN, your Physics Sports Network. Tonight's story will be about physics in baseball. To start off the night, we'll be discussing two-dimensional motion and how it applies to throwing. In this diagram, we see that two-dimensional motion is broken down into horizontal velocity and vertical velocity. A proper throw must have a proper combination of both. Because gravity is always accelerating downwards, without enough vertical velocity, a horizontal throw with no vertical velocity will just immediately go straight down. Similarly, a throw with a lot of vertical velocity but no horizontal velocity will travel very far up in the air but won't go very far on the x-axis right here. A proper throw will have enough horizontal velocity so that the ball can reach the second player before gravity can pull the ball down. Moving on to Newton's three laws. In Newton's first law of motion, Newton explains that an object will remain at rest until a force is acted on it. For example, in baseball, we see that a ball will remain fair until another force will be used to push the ball foul. In Newton's second law of motion, Newton explains that force is equal to mass times acceleration. This means that a very big bat with a lot of acceleration can have the same amount of force as a very little bat with a lot of acceleration. Moving on to Newton's third law of motion, every action will have an equal and opposite reaction. This means that a bat swung very hard will similarly hit a ball very hard, or a bat that isn't swung very hard, for example a bunt, will not hit the ball very far at all. Circular motion in baseball. Circular motion is used when the pitcher is pitching. The circle is the rotation the ball makes as the pitcher is throwing. At any given point, the ball has a velocity with the direction coming outside of the circle. But because of the centripetal force pulling the ball to the center of the circle, the ball does not fly out until it's released by the pitcher. Because of the centripetal force, the ball, when released, is pulled backwards, back into the circle, and this gives the ball the backspin that you see in pitches. Moving on to friction. Friction is a force opposite of the applied force that resists forward motion. As you can see here in the diagram, no two objects are perfectly smooth. This means that there will be always some resistance when one object is sliding against another. Or as you see in baseball, when a player is sliding in the base path. The force of friction will slow a runner down so that he'll hit the bag with less force as originally applied. The amount of friction is determined by the coefficient of friction, which is equal to the force of friction over force normal. Force normal being the force of the ground resisting the force of gravity, which is described by Newton's third law. Every action must have an equal and opposite reaction. So, when a player is sliding in the base path, the force of friction determines how slow the batter will be when he reaches the base. Finally, in baseball, we're going to discuss work. work is equal to the change of energy. As we see here, friction does work because it changes the amount of kinetic energy the ball has when it slows the ball down when it's rolling on grass. To determine how much work the grass is doing here, you must take the kinetic energy of the ball when it's rolling on the dirt and the kinetic energy of the ball rolling on the grass, and you must find the difference. The difference of the two kinetic energies is the amount of work friction of the grass has done on the ball. That has been your story tonight. Please tune in another time. Thank you.